lab number 1. Molar mass by, I think it says molecular weight. No, molar mass. That's right. By freezing point depression. Okay. So most lab exercises have a central theme, an objective, if you will. And the title tells you what we're after. We're after the molar mass. And we're going to use a colligative property called freezing point depression. That means we're going to use this formula. And we don't have to put the I correction factor in it because benzene doesn't dissociate. So I would be 1. And we would have the K for freezing point depression and molality of the benzene. So this is going to be for lauric acid. That K value. And this molality for benzene. All right. Oh, there are some discussion questions, but let me hold that for just a second. Yeah, the discussion questions are those that I'm supposed to go over with you in class, and the pre-labs and post-lab questions are those that you deal with. 1 second. All right. So on the first page, you have a pre-lab question, but it also gives you information for the lab itself, because in here we have this sample problem, lauric acid and benzoic acid, but we're given the value here is given in that pre-lab question, and it's 3.90 degrees C kilogram per mole. Okay. All right, so what are we going to do? Well, what are you going to need? You're going to need boiling water. Right? That's what you use to melt the lauric acid. We're going to measure the melting point of lauric acid in reverse, and it should happen at exactly the same temperature as melting. The freezing point and melting point are the same. So we're going to melt the lauric acid, a known mass. We have to know the mass because of molality. We have to know the mass of the solvent. So I think it's something in the neighborhood of 8 grams. Yeah, 8 grams. And you don't have to measure out exactly 8 grams. You just measure out whatever you want, close to 8, and then get the exact value. So it could be 7.99 or 8.1, whatever. But you need to know exactly what it is. So you need that. You need lauric acid. And you need benzoic acid. Benzoic acid. You need thermometers. You need 2 of them, I think. 2 thermometers. You need a timer of some kind, because you're going to measure the temperature of your cooling substance over time. I think every 10 seconds or 30 seconds, every 30 seconds, you'll record the temperature, and that way you can plot the cooling curve. And what you'll see is over time, in seconds, temperature, it will gradually cool like this, and then it'll get to a certain temperature and flatten out. So where it flattens out, and usually if we expand that, we would draw, and that would be your freezing point. Okay. The problem with these amorphous solids, like lauric acid and like benzoic acid, they don't have very well defined freezing points. The ionic solids, yeah, I mean they have a freezing point, melting point, boiling points are very well defined. They happen just like that. So it's a very sharp break. But for these amorphous solids, they'll kind of do a gentle thing like that. But eventually, it will flatten out, and you could read it maybe 3 times in a row, and the temperature is not changing. That'll be your freezing point. And you do that for the pure substance and for the mixture, the solution. So you do this first, the pure, and then the freezing point is going to be depressed when you add some benzoic acid to it. So it's going to follow, maybe not exactly like that, but it'll be similar, and it'll go down here like that, and then it'll flatten out. So you have a different temperature right here. And the difference here is the delta T. Okay. That's what you're after. You want that delta T. And then we know the delta T, we know the K, so we can solve for the molality of the benzene. So once we get the molality of the benzene, that's what? Moles of benzene per kilogram of lauric acid. Okay. Now, we got that one from this operation here. We know the kilograms of lauric acid because we measured it in grams. So you have to convert it to kilograms, correct? Right. So you know that one, you know that one. You can calculate the number of moles of benzene. So that gives us the moles of benzene. What's the mass of the benzene? Well, you measured it too. Before you put it in here and did that one, you measured out about 1 gram, I think. And you know the exact value for that. So that way, we calculate the moles here. We know the mass from here. We can calculate the molar mass and compare it to the accepted value. Okay, so that's why activity 1 and activity 2. The first activity 1 is pure solvent, and the activity 2 is the mixture. And then you've got tables over here to help you fill it out. But what I would do is just transfer that table into your notebook, because you're going to be using your notebook, not this thing. Okay, do we need to do the pre-lab question, or you think you can do that? I described the whole procedure right here. Oh, discussion questions. Those are the ones that I'm supposed to do with you. How are we doing on time? Okay. Yeah, we're good. There are some other things that we're going to need. Like we need big tubes, about that big and about that big around. We need a funnel, because you want to add the material to the tube in such a way that it doesn't get stuck around the top, because you want it to be down where the boiling water is. And you'll have a thermometer stuck in there. Oh, it's about time Sam showed up. Okay, so discussion questions. Number 1, boiling point elevation and freezing point depression are examples of what type of property? Remember what it's called? Colligative properties, right? Colligative. Those are examples of colligative properties. What quality must a solute have to affect a change in boiling point or freezing point? Let me put it this way. What would happen if the solute were volatile? You would never know exactly how much you have in solution because some of it might evaporate, right? So the solute has to be non-volatile. What's the definition of molality? Oh, well, just molality is moles per kilogram, moles of solute per kilogram of solvent. Okay. What's the molality of a solution that contains 1 mole of non-volatile solute dissolved in 2 kilograms of solution? Okay. So that's 1 divided by 2 is 0.5 molal. Correct? 5. Let me see, is that the last one? 5. Yeah. So 5 asks, calculate the freezing point depression of a solution that contains 1 mole of non-volatile solute and 0.2 kilograms of water. So delta T equals the value for water, 1.86 degrees C kilogram per mole, right, times the molality of this compound, which is 1 mole per 2 kilograms. So 1 mole per 0.2 kilograms. There you go. Yeah, freezing point depression. So this is 0.2 into 1 is 5, isn't it? So 5 times 1.86, which should be 9.3 degrees C, is the freezing point depression. So whatever the freezing point is, we're not told that, it will be depressed by 9.3 degrees Celsius. Okay. Can you do the pre-lab? Or do you want to do that one? Because if you can do the pre-lab, it's the same problem that you're going to encounter in the lab itself. It's just that they're giving you the values here that you determine. You're going to determine your own values. They're giving you a set of numbers here, and you're going to do the calculation. All right, so let's do the pre-lab. So a student found 7.98 grams of lauric acid, which is the solvent. 7.98 grams, and it froze at 43.75 degrees C. So that's the freezing point of the pure solvent. When 1.03 grams of benzoic acid is 1.03 grams of benzoic acid in 7.98 grams of lauric acid. Now the freezing point changed to 39.43 degrees C. Okay. So what's the delta T? Get out our calculators. 43.75 and 39.43. 4.32. Delta T equals 4.32 degrees C. All right. So that is equal to, and this is the lauric acid freezing point constant, 3.90 degrees C kilograms per mole. And then molality. So molality is going to be this one divided by that one. correct? Right, this goes in here, that goes in there, we're left with this one. So to solve that equation, we say this one is equal to temperature divided by the K value. Right, so let's do that. 3.9, 1.108 molality equals 1.108, and molality is moles of lauric acid, excuse me, wrong. Benzoic acid per kilogram of lauric acid. There you go. That's the molality of our solution based on this data. Okay. So if we're going to calculate the molar mass of benzoic acid, what do we need? Molecular weight of benzoic acid equals moles of benzoic acid per, grams or mass of benzoic acid per mole, grams per mole. Okay. What's the mass of benzoic acid? 1.03 grams, correct? So we got the mass, grams of benzoic acid. What we need is the moles. So how do we get moles? Well, molality is this many moles of benzoic acid per kilogram of lauric acid. How many kilograms of lauric acid do we have? 7.98 is what kilograms? All right, we need to move it 3 places. 1, 2, 3. 0.00798 kilograms of lauric acid. So if we multiply kilograms of lauric acid times molality, it will cancel the kilograms. Right? 1.108 moles of benzoic acid per kilogram of lauric acid times 0.00798 kilograms of lauric acid. That cancels kilograms here, kilograms here. That times that is the moles of benzoic acid. Let's see, 0.00798. And I get 8.839 times 10 to the minus 3 moles. So this goes in here, grams per mole, 8.839 times 10 to the minus 3 moles. 1.03. Make that divide, and I get 117 grams per mole. Give or take. Rounding errors included. Okay. So how does that compare to the accepted value? Let's see, is the accepted value reported here? 122 grams per mole is the accepted value. So if we say, what's the percent error? It's the calculated error. I mean, the calculated value. Calculated value minus the accepted divided by the accepted times 100. So that would be 117 minus 122 divided by 122 times 100. Correct? Now this will give us a sign. It'll be a negative value because that one's bigger than this one. And that means that our answer is -% error. But sometimes you don't have to do that. You could just take absolute value and then the order doesn't matter. 117, 122 subtracted, divided by 122 times 100. I get -4.09. So percent error is -4.09%. Okay. There were several steps involved, but if you keep your eye on the prize, which is that molecular weight equals moles, mass per moles, grams per mole, then you know what you're looking for. You're looking for mass, benzoic acid. Okay, we got it right here. And you're going to weigh that out yourself. And moles is derived from someplace else, back over here. So if you know what the end game is, then you can usually do the multiple steps to get that information. All right.
We did the discussion questions, but where are they located?
They're not.
Oh,
Yeah, they're in my document.
okay.
Yeah. The reason I did that, I didn't want to put them in yours because you might think that you have to use them in your report, and you don't. They're just for general discussion. Yeah.
That's what I was confused about. How am I going to put this?
Yeah, sorry about that. Okay. I think we're done for today.